Hi, welcome to the video tutorial explaining the operating instructions, software and joystick control, and main imaging modes of the MCRL700 3D microscope from Microcubic. Let's get started. First, ensure that the microscope is assembled correctly, the USB cables are plugged, and it's powered on. If not, please check the other video tutorial about the initial setup. On the MCRL viewer software, connect to the COM port from the top right corner and connect to the camera from the bottom left corner. Go to the camera options to change the exposure to the auto mode. You can switch to manual exposure later if needed. Now you should be able to control all motorized actuators using the control arrows. It is possible to control the actuators in 3 different modes. In the free mode, the longer you press the arrow, the faster the actuator travels. In the relative and absolute movement control, on the other hand, they move according to the distance and speed values you enter. The system features a scale bar that dynamically changes according to the magnification level. It can be enabled by choosing the lens from the lower left corner, provided you have already imported the lens calibration data from the settings menu. When the scale bar is enabled, you can also control the XY stage using mouse clicks on the camera preview. The microscope automatically moves the sample and centers the point you click. Additionally, you can use the software to change all parameters of the illumination sources, such as creating different lighting patterns by individually activating the LEDs or by changing the color of the ring illumination. There are other ways to control the microscope. For example, every module has integrated touch switches to control the actuators or turn on and off the illumination sources. These switches also have more advanced functions, which are discussed in other tutorials. The joystick can control all 7 motors in 3 distinct modes. Pressing the top physical button switches the joystick to the XY mode, where pushing the knob left, right, up, and down moves the sample accordingly. The touch switch on the right activates the tilt mode, where both primary and secondary tilting axes are controlled. Finally, the touch switch on the left activates the mode where left-right movement controls the sample rotation, and up-down controls the camera axis, effectively changing the zoom level. In every mode, rotating the knob clockwise or counterclockwise controls the Z-axis to adjust the focus. Note that the more you push the knob, the faster the actuator moves, so a slight touch is enough for precise positioning. The zooming is done by moving the whole camera module closer to the sample using the Z-axis, while moving the CMOS image sensor inside the housing away from the objective lens using the C-axis, and just to opposite to zoom out. Note that this microscope does not have a continuous zoom function, so both C and Z actuators must be adjusted to keep the sample in focus for different zoom levels. In general, the camera axis is used for zooming, and the Z-axis is used for focusing. After some practice, you can control both linear actuators simultaneously to zoom in and out more continuously without losing the focus. Let's now review the main imaging modes of the microscope, starting with the reflected light microscopy and different illumination options. For 3D imaging of reflective samples, like semiconductor chips, the curved illumination source is fixed to the articulated arm. To capture the reflected light, the camera needs to be tilted at least 10 degrees, and the light source should be moved forward to bring it as close as possible to the sample. When properly positioned, this light source can always illuminate the sample for almost every imaging angle thanks to its curved profile, so you don't need to adjust its position continuously. You can switch to the high zoom lens for applications requiring a higher magnification level. Note that this lens has a much lower working distance and dynamic range than the other lens, so it must be closer to the sample. You can manually lower down the camera module if needed, and then use motorized positioning. The microscope is provided with a high-power light source, which is compatible only with the high-zoom lens. Regardless of illumination type, you can enable the scale bar for this lens by selecting Lens 2 from the lens list. You should be able to resolve features as small as a few micrometers. For opaque and non-reflective samples, the ring illumination can highlight some additional microscopic features or defects. Individual LEDs can be controlled to create a dark field effect, and the color of the illumination can also be controlled or programmed from the software using red, green, blue, and pure white channels or their combinations. Note that you cannot move the camera too close to the sample when the ring illumination is attached. Let's now move to the transmitted light microscopy mode, which can be used to image transparent samples like microfluidic chips. In this mode, the curved illumination is placed underneath the sample, as shown in the video. Then you can use one of the provided sample chucks to fix your sample. Smaller samples can be placed on a glass slide or fixed using custom-designed holders. For 3D imaging, the camera is tilted to negative viewing angles. The high zoom lens and the ring illumination can also be used in this mode. In the transmitted light mode, it is important to rotate the camera preview on the software. Otherwise, the captured images and videos will appear upside down. Also, remember to remove any obstacles on the path of the tilting module. The system is also provided with a spot illumination source with a high-power LED. This light source is particularly interesting for imaging biological samples using the high-zoom lens. It can be lifted to bring it closer to the sample, and its illumination angle can be adjusted manually. This module has a spring to prevent damage if the stage accidentally collides with it. It also has a manually operated diffuser film, where sliding the film out can enhance the contrast in some applications by illuminating the sample directly with the point source. So far, we have discussed imaging in transmitted light and reflected light modes using camera tilting. But this microscope has another feature that allows you to tilt the sample instead of the camera to capture 360-degree videos of the sample. First, extend the XY stage by pulling it out from the thumb screw underneath. Then, unscrew the rotary actuator, slide in the screws on the other side, and fix it back 90-degree rotated. Use the provided spring-loaded holder to clamp the sample to the rotary actuator. You can then tilt the sample 360 degrees and adjust its position using the XY stage. Optionally, you can tilt the camera for optimal illumination and viewing direction. The clamping force of the holder can be adjusted using the provided screwdriver. Please get in touch with us for customized holders for your specific samples. Finally, the microscope's wide-angle objective lens can be used to observe larger objects that cannot be imaged using traditional microscopes. Different light sources and custom-designed and 3D printed sample chucks can be used depending on the sample type and the imaging mode. Because such macro objects require a larger illumination source, you can also consider lights and softboxes used in classical photography. And thanks to the system's dual-axis tilting mechanism, you can even image objects placed outside the microscope's main body. For all objective lenses and imaging modes, we recommend using the provided iris diaphragm to control the aperture. This is an essential component in almost every microscope and photography tool, and is used to regulate the incoming light and adjust the depth of field. Depending on the sample type and the tilting angle, you can adjust the aperture and the exposure level for the optimal image output. If you select Auto Exposure from the Camera Options menu, the camera will automatically adjust the exposure level even for small apertures. But note that the auto camera settings may increase the noise in the image when the aperture is too small. Alternatively, you can fully open the aperture or remove the diaphragm, thus reducing the depth of field, and perform an automated focus stacking step to create an image where every point is in focus. Please follow the software user guide for more on this. We hope that you found this tutorial useful for your imaging applications. Thank you and goodbye.